All right, switching gears here. This example of the hypophosphatemic, I hope I'm saying that right, hypophosphatemic rickets is an example of a dominant trait. And the tough thing about pedigrees that have dominant traits is that an individual only needs one copy of that allele in order to show the trait. So oftentimes with the females, we have to look at what their children are or what potential combinations they could have gotten from their parents. We have to kind of look at both. Males are still really straightforward. They're either going to have the trait or not. And so when I'm filling this out, I like to start by looking at the males, because the ones that are not shaded are the ones that are normal in this case. So I'm going to start off with individual 2 and kind of just work my way around the pedigree. In individual 2, they're going to be X lowercase r y. Again, they do not have this trait, and so their one copy is going to be recessive. So I'm going to go ahead and copy that, and all of the males that do not have the trait are going to get that same genotype. All right, the next thing I'm going to do is fill in any male that has the trait, because again, they only needed one copy. So we have X, capital R, and Y for this male, and it will be the same for this male over here. So now I need to go back and figure out what the genotypes are of the females, which tends to be a little bit more challenging. The first type of female I'm going to actually start off with is a female that is not affected. So individual 6 on here is not affected by the disorder. And it's key to starting with that because we know what the genotype is. She must be carrying 2 recessive copies in order to not show the disorder. Again, this disorder is a dominant disorder, and so they only need one copy of the dominant allele. She is going to actually be key in our understanding, in addition to individual 5, in understanding what the genotype was of the mother. So a reminder to you, where did individual 5, we're looking right here, where did individual 5 get their Y chromosome from? Well, they got it from dad, right? So that came down from dad. All right, where did they get this X chromosome from? They got it from mom. Okay, so that copy of the X chromosome they actually got from mom. So we could write in there that that is X lowercase r is the allele, or the chromosome, sorry, that they're going to give to their son. But they have the disorder. Okay, they've passed this disorder down to their other son right here. So we know that mom must be carrying a copy of the dominant trait because she is showing the illness. So we knew that going into it, but we also know that she is carrying a copy of the recessive allele because her son had it. If that wasn't convincing enough, here's another way to look at it. Individual number 6, which is their 4th daughter, would have gotten this version of the allele, a normal allele, healthy allele from dad. Well, she's healthy herself, so mom must have been carrying a copy of that as well. All right, so let's look at individual 4. What must her genotype have been? Well, the only chromosome that her dad could have given her was a allele for a normal X, right? But mom must have given her the allele for the defective X because she's showing the illness herself. All right, and we can't confirm anything more beyond that. That's a pretty conclusive example there. We don't have to worry about like seeing if individual 4 has children, what her children would be, because we know what mom gave her, we know what dad gave her. All right, so then the last ones we have to look at are individuals 8 and 10, and this comes from individuals 6 and 7 reproducing. So if you just kind of narrow in on that, dad is automatically passing on that defective allele to his daughters, right? Automatically giving that to his daughters. Mom has no option other than to pass along a healthy allele to her daughters. So individuals 8 and 10 actually end up being pretty straightforward. Now, when I say defective, I'm just referring to the fact that that particular illness is not maybe one that you would want to pass along to your children. Some of these inherited disorders, the dominant or recessive disorders, people are actually like, hey, that's awesome that I have that. But most of the ones that we are studying right now are things that we consider to be genetic illnesses, and therefore we would say that it's a defective allele. It's one that is going to be causing something that is not beneficial, or it makes the individual less viable in life. All right, hopefully that helps you a little bit. Again, with something that is dominant, I like to start off looking at the males' genotypes simply because they're easier to figure out, and then go back and look at the females that are not affected because we automatically know they're carrying 2 copies of the recessive allele, and then go back and do some problem solving and figuring out what the affected females' genotypes would be. You know that they have to have at least 1 copy of the affected allele, so 1 copy of the dominant allele, but they could have 2 in some cases, as you saw in some of the follow-up example problems to this one. All right, I hope that helps clear up a few things for those of you who are getting confused on these concepts.